Good morning, class. Algebra 2 honors. We're going to go ahead and do one example of solving equations, which is connected to the evaluating that we did in class today. All right, here goes. Okay, so I'm going to continue this with 6.4. Okay, 6.4 continued. And we're going to do the solving portion, just a little bit of examples here. Okay, so first thing we're going to talk about with solving is inverse operations. Now we are dealing with powers and roots, okay? And so I'm going to put a little PEMDAS over here. And I'm going to group my operations by inverses. So adding and subtracting undo each other. Multiply and divide undo each other. But when I get here to exponents, which is where your powers and your roots fall, there isn't really a grouping with it, okay? And so we're going to look at how to undo powers and roots. All right, so we have x to a power, right? And I'm just going to say equals 2, okay? And then I'm going to say root x to the, we'll just leave it as a 1, equals 3. Okay, so I've got a power and a root. And what I want to do is figure out how do I undo, all right? Keeping in mind that as we're going to start solving here, we want to get x by itself. Oh, well, if I have a power, I'm going to use a root. Okay, so I'm going to say a root that is matching the power. But we're solving here, property of equality. We have to do the same thing on both sides. And notice here, even if you write this, okay, in exponent format, you get x to the first power. And so this gives us x equals the p root of 2. Okay, that's good. So the root, the matching root, undoes the matching power. Okay, so now I'm going to look at the root. Okay, so think about those. Okay, notice that I parentheses both sides of the equation. And if I want to undo a root, I have to do the matching power. Okay, and if I think about this in exponent form, okay, I end up with x to the first equals 3 to the r. Okay, so what did I learn here? Okay. Matching power, root are inverse operations. All right. Okay, now let's see if we can't extend that to x power root combination equals 4. Okay, what am I going to do in order to undo that exponent? Now notice our goal is to end up with a 1. Okay, so I need the power and the root to kind of cancel each other out. Okay, so I'm going to write this in radical format. Okay, so that's x to the p root r equals 4. And then I'm going to do it in 2 steps. Now, in this particular case, I left the p inside the radical, so I'm going to do an r, right? Let's do the r. So the r's cancel out power and root, and we have x to the p equals 4 to the r. But now I need to get rid of the p, so I'm going to do the root. Okay. This cancels out, and over here we just get the p root of 4 to the r. That's it. Okay, not too bad. Now, I'm going to write down here. So, inverse. So, what did I do? I did an r power, and I did a p root. Okay, that's what I did. Now, radical form is kind of useful, but it doesn't mean you can't leave it in exponent form. What if I wanted to do this in 1 step? Okay, so I did an r power and a p root. An r power and a p root. Oh, okay, look at that. My exponent rule says that we multiply our exponents. Well, that's just equal to 1. 4rp, which is x equals, okay, power root, which is exactly what we got from writing it in radical form. Okay, so here's the question. What do you use to get x equals? What power root do you use to get x to the first? Okay, that's what I'm asking. What power and root do you use to get to x to the first? Use a power 2 and a root 3. Power 2 and root 3. Right. Power 2 and root 3. Okay, now we just practiced this. So I get x equals 4 cube root of 4. That's why we practiced evaluating. All right, so let's turn our page and look at a couple more things on how to undo the powers and roots. Let's do some examples. Okay, so these are just going to be 1 or 2 step equations here. Let's say I have x squared equals 9. Okay. Let's do an equation that says the cube root of x equals -3. And then let's do 1. And it says, x to the five halves equals 32. Okay, so I'm going to start with my red marker, and all right, so I have a power 2. Means I'm going to use a square root. Oh, all right. So x equals the square root of 9. But be careful, guys. That's a degree 2, okay? Which means there's supposed to be 2 solutions to that. And so we actually get a plus or minus, which means we get x equals plus or minus 3. Now, one thing to note here, we're going to investigate this property that says, okay, that this actually simplifies, right? We know it simplifies to x, but it actually simplifies to absolute value of x. And so what happens, how do you solve an absolute value equation? You split it apart into the plus or the minus, which is x equals -3, x equals +3. And so this combination right here, okay? Now, it actually matters what order this shows up in, okay? Because it matters what's written on the page. And so when you have an even power, okay, notice that we started with an even power. Then you get an even root. The result, okay, x to even power, then you get an even root, and then you get an odd result power. Notice that this is resulting in a 1, okay? So let's look at it. First, if you start with an even power, and then you get an even root, and then you get an odd result power, you will use the absolute value. And that's one of these tricky little pieces we're going to look at a little bit further. Okay, so I'm just going to put a little star here and we'll continue to discuss that. All right, so I'm going to cube, okay, and so I know that I get x equals -3 cubed, which is -3 times -3 times -3. So we get x equals -27. All right, last one here, power 2. Okay, notice that we started with an even root. That is not this, okay? All right, so here we go. We get x equals, okay, power root. So I'm going to change it, right? See that? Okay, so the fifth root of 32 is 2, and then 2 squared is 4. All right, nice practice. I will follow up with some more examples a little bit later.